Assalamualaikum and hello. My name is Nur Jannati binti Zahrin. With me today, Mohamad Firdaus bin Rosli and Mohamad Zulhasnan bin Zahari. We would like to present about MXenes and Boronphene. This is our content for this presentation. We will explain briefly about MX and details about MXenes, Boronphene, how to synthesize MXene and Boronphene, and their applications. What are MX? MX phases are a class of layered ternary carbides and nitrides with the general formula Mn+1 AXN, where M is an early transition metal, A is a group element, mostly from groups 13 to 16, and X is carbon and or nitrogen. These materials are structurally layered with each unit cell consisting of N layers of MX interleaved with a single layer of A. MX can be classified based on the value of N in their chemical formula, which determine the number of metal layers in the structure. For N equal to 1, the structure has 2 layers of the transition metal, 1 layer of A group element, and 1 layer of carbon or nitrogen. For N equal to 2, the structure has 3 layers of the transition metal, 1 layer of A group element, and 2 layers of carbon or nitrogen. Next, what are MXenes? MXenes are a family of 2D transition metal carbides, nitrides, and carbonitrides, which derive from MX phases. They are typically produced by selectively etching the A layer from MX phases, resulting in a structure of Mn+1 XN layers. M is an early transition element, such as titanium, vanadium, niobium, and etc. X is carbon or nitrogen, with N ranging from 1 to 4. And Tx represent the surface termination, which typically hydroxyl, oxygen, or fluoride groups, with N+1 layers of M covering the N layers of X in the arrangement. Figures below shows the example of MXene in different N value. MXenes are a versatile family of 2D materials that can be classified based on the structure. First, simple structure, called a single metal element structure. Second, ordered double transition metal MXenes. It has unique electronic properties due to the ordered metal layers. Third, solid solution MXenes, which allow property tuning through varying the metal composition. And the last one is ordered divergency MXenes that exhibit the increased porosity and unique surface properties. This schematic shows the example of synthesis process of 2D MXenes using titanium aluminum carbide. The process starts with MX phases is treated with the hydrofluoric acid, then A layers or aluminum are selectively etched. Selective etching means removal of A element without significantly disrupting the MX layers. This process often leaves the MXene surfaces terminated, which can be further modified to tune their properties. Next, sonication involves using ultrasonic waves to agitate the solution containing etched MXenes and break van der Waals forces that hold the layers together. This process helps to exfoliate the multi-layered MXenes into few layer or even monolayer sheets. Delamination is the final step where the few layer or monolayer MXene sheets are separated. This step often involves the addition of intercalants such as DMSO to help further separate the layers by intercalating between them. MXenes can be altered by several ways. The first one, MXenes can be tuned by adjusting the number of layers through selective etching or stacking. Secondly, MXenes allow substitution of metal and X element to create diverse composition. Number 3, surface termination of MXenes can be adjusted during synthesis or through post-treatment. Next, MXenes can be altered by selecting specific MXene sizes, and the last one by intercalating various species into the structure. Today, we explore various methods to alter the MXenes for tailored applications.
Now, I will explain on the characteristics of MXenes. It has 5 properties, which are optical properties, mechanical properties, chemical properties, electrical conductivity, and specific area. For optical properties, MXenes have strong light absorptions in the visible and infrared regions. Mechanical properties, MXenes have high mechanical strength and stiffness due to strong metallic bonding within the layers. For chemical properties, due to their surface terminations, MXenes are generally hydrophilic, which allows them to be easily dispersed in water and other solvents. For electrical conductivity, MXenes are known for their exceptional electrical conductivity. This property is due to the presence of metallic bonds and a high density of free electrons. And last properties, specific surface area. MXenes have high specific surface area, especially when exfoliated into single or few layers sheets. Next slides, I will explain on applications of MXenes. Number 1 is energy storage materials. MXenes exhibits high electrical conductivity and large surface area, making them excellent materials for supercapacitors with high capacitance and fast charge or discharge rates. Number 2, electromagnetic interference (EMI) shielding. MXenes have excellent electrical conductivity and are used in coatings and composites to protect electronic devices from electromagnetic interference. Number 3 is optoelectronics. MXenes are used in photodetectors due to their plasmonic properties and strong light absorptions. Next part, we go to the boronphene. So, what is boronphene? Boronphene is a single layer of boron atoms that has recently generated significant interest due to its ultra-low molar mass and unique properties. Unlike graphene, boronphene exhibits various polymorphs such as stripe beta-12, X3, and honeycomb structure, all of which have been found to be metallic. Despite bulk boron being semiconducting, researchers are keen to explore the semiconducting 2D phase of boron that also known having a high metallic conductivity and good thermal conductivity. Boronphene's unique structure and potential semiconducting properties position it as a promising candidate for future advancement in the semiconductor industry, potentially serving as an alternative to silicon and driving the next generations of electronic devices.
Next, we move to how synthesis the boronphene. The first one is molecular beam epitaxy. Basically, monoatomic layer of boron is deposited on different metallic templates such as silver, gold, or copper. So basically, this synthesis undergo a controlled vacuum and temperature conditions. Second method is chemical vapor deposition. So this chemical vapor deposition uses the principle of pyrolysis of the boron source under a high temperature and vacuum conditions. The volatile precursor decompose at a high temperature and metallic vapor that deposited to the substrate. Next is mechanical exfoliation. So basically, mechanical exfoliation involve the mechanical peeling of the bulk boron crystal. It is similar like the graphene synthesis. So it is using the adhesive tape to synthesize the boronphene. Other method to synthesize the boronphene is the electrochemical synthesis. So basically, an electrolytic boron dipped in a suitable electrolyte and electrode is introduced in the setups. So a monoatomic layer of boronphene is deposited on electrode due to redox reactions. The last one is sonifications assisted liquid phase exfoliations. So this method used to produce boronphenes by separating layer of boronphene from the bulk materials in a liquid. So this method using the ultrasonic wave and centrifugation. Now let's discuss about the boronphene's applications. The first one is alkali metal ion battery. Basically, the crucial and the major parameter for the electrode materials are the good ionic conductivity, good electronic conductivity, suitable voltage at the high capacity. Boronphene, known as the lightest second D material, have the high surface activity and have the metallic band structure that's suitable for electronics conductivity. So, the boronphene is the suitable materials that used for the alkali metal ion battery. The other applications of boronphenes is the hydrogen storage. Boronphenes is a good materials for the hydrogen storage because it have the lightest second dimensional material and can result in a ultra high hydrogen storage capacity.
That's all from us. Thanks for watching this video. Bye.